So welcome, Rohit, Ginger, and Heather, and Karpash. Thanks for coming, and hopefully the rest will come also. Let me tell you the plan, and let me share my screen so that we can all see. So the plan of the day today is what we'll do is, as always, I'll start out with any questions you might have, and that could be about anything. And then after that, we're going to look at the area of a rectangle. And I think we talked about it a little bit, but we're going to get a little bit more involved this time. And I'm going to kind of show you how it's used in statistics. And we'll look at finding the height of the rectangle, finding the base of the rectangle, et cetera, et cetera. And then after that, we're going to look at what's called factorials. So it's a piece of arithmetic that you may not know. It's kind of, there's like, you start with addition, and then multiplication is repeated addition, and then factorials turn out to be some kind of interesting repeated coming down multiplication, as we'll talk about. And then we'll look at combinations. And we'll see how do you find combinations, what do they mean? So it has to do with how many ways are there of selecting stuff. So that's what combinations is all about. So that's the plan. I want to mention something. The exam happened, and it was pretty successful. So I'll let you know. Again, for sure for you, but 90% of the students who took the exam passed the exam. So that's a pretty high percent rate. I'd like to see it be 100%, but 90 is a lot better than what happens in some other classes. I'll tell you that. So 90% passed, and that's a good sign. Some people got 100%, which is like wonderful, and others, did pretty well, and passed or did a very good A job or something like that. If you didn't pass it, it doesn't mean you can't pass the class, but it does mean you probably need to push it a little bit harder. We have tutoring pretty much all day long, 5 days a week. I think there might even be a little on Sunday too. And you can get help from a tutor any of those times. You can also get help from me if you post in the Q&A forum or ask me. And of course, you get help during all these webinars. I'm always happy to help out. So that's just a note. We're here to help. I'm here to help. The tutors are here to help. The college is here to help you out. I know it's challenging that we can't actually go to the college. It's driving me crazy. I'm not sure about all of you too, but we're doing our best in these kind of situations. But this class is supposed to be online anyway, so you don't need, even if the coronavirus hadn't happened, this is still an online class. That hasn't changed at all. What does change is that every other class is now online. Okay, we don't have anything that's face-to-face. Okay, and that's pretty much going to be true of summer and most of winter, most of us fall classes. Are there any questions about anything before we move on to stuff? Any questions? Okay, just a note, again, the way because this is an online class, the way I make it happen is that there's two major exams. There's a midterm and a final. So the midterm was at the halfway point, and the final is at the end point. So just note that we're now past the halfway point by definition, because it's a 12-week class, and we have now done about 6.05 of weeks. So we're just a little past week 6. So we're past the halfway point. So hopefully it's going okay. I am always happy to hear suggestions you might have to improve it. If there's something you want me to do for you, either whether it's during the webinars or added support that I put on Canvas, whatever it might be, I'm here for you and happy to help you out. So just let me know. You now had half the class, so you kind of have a feel for how it's going. Okay. The one thing I'm not going to do is apologize that we have to be online, because this was always planned online. Okay. Unlike my other classes that I teach, where I did have to, like, I don't know about apologize personally, but feel bad. This one's an online class, so there's no No surprises on this one. So any questions? Okay. If you have questions anytime throughout, just ask me. Always happy to help out. All right, so I have a question for you. Let's see if you remember.
Huh?
So
What
do
did
you
he say?
remember the formula for the area of a rectangle? Anyone remember the formula for the area of a rectangle? Good, good, good. So the formula for the area of a rectangle is that the area of the rectangle is equal to the base of the rectangle times the height of the rectangle. So let me just type that out. So area of a rectangle. And that is, again, area is equal to the base times the height. Often written as A is equal to BH. Okay. Sometimes you'll hear length times width. The reason why I don't like length times width as much is that L is a terrible variable because L looks too much like a 1. So I like B times H because there's no confusion on being a number. None of those things look like numbers. Okay, so let me do some highlighting because this is really important. Because that is, if you can do this correctly, then you should be able to do any problem from the area of the rectangle formula, area of the rectangle assignment. So let's do a example. Okay, suppose that the weight of a medium-sized potato, just because I was looking at potatoes before we got in here, because I think I'm having that for dinner partly, is uniformly distributed. Between, and I'm going to make this up, about 4 and 9 ounces. I have no idea how big a medium-sized potato is, but sounds good. Okay. The rectangle below shows this situation. The probability that a potato is between 2 different ounces. Let me just write 2 different measurements. Is the area of the rectangle. As shown. The area of the larger rectangle is always 1. Find the probability that a randomly selected potato is, I guess I should say, weighs between 3.2, 5.2 and 6.7 ounces. And now let me draw a picture for you. So I purposely made this long And the reason why I made it long is this is how you're going to see it in the stats class. Okay, finding the area of a rectangle, if they just give you a baseline height, you multiply the numbers, you're done. But that's not what's going to happen in the statistics class. What's going to happen in the statistics class is it's going to be a big paragraph like this, except the only thing is they're not going to tell you that sentence. That's something you're supposed to just know in statistics. In this class, you're not responsible for knowing that. So that's why that's the only difference between what you'll see in the stats class and what you see in this class is that in the stats class, you won't be given this highlighted sentence. In this class, you will, because again, I can't expect you to know statistics. The other thing you won't be given is a picture, but I'm drawing you the picture because again, that's something you're going to be learning how to do in stats. So we have again, oh, I should write this down, 4 to 9, so I don't forget. And then 5.2 to 6.7. So I'm going to draw a picture for you. So we got that one. Then another rectangle. That one, and let's color it. And let's put some numbers in. So the first number was 4, and then 5.2, and then 6.7, and then 9. I'm purposely doing this and showing you me doing this instead of just starting it out like the picture. Any guess on why I'm purposely showing you how I'm drawing all this? I don't see your guesses. Okay, there's a reason. The reason is because you're going to have to do it when you get to statistics. Okay, this class it'll be given to you, but I want you to see the process. So when you get to stats, you'll have seen it before and then you'll be ready to do it. And that's what I'm hoping you get out of this class is that you'll get all these processes, you'll remember them, some that you do yourself, some that you watch doing. And then when you have to do it yourself, the whole thing, you'll be able to at least be a little more comfortable with it. I'm gonna put one more. There we go. And that's H. Okay, so now we got to solve this problem. Okay, there's a lot of information here. Any idea on how to start this? Any idea on the first thing we need to do? Find the base. Okay, there's actually more than one rectangle here. It turns out it's not the base that we need to find. That's actually going to be just a subtraction. That won't be too hard. There's something else we really need to find. The hint is it's the only thing up there that you don't know just by looking. Yeah, we need to find this height. So you need to find the height of the rectangle. So let me remind you that the area is equal to the base times the height. I'm going to be writing that a lot. Every time you're dealing with rectangle problems, it's a good idea to write that down because then you can just plug in what you know. Okay, well, for the large rectangle, do we know the area? Do we know the area? For the large rectangle. Yeah, the area is 1 because it's given in the problem. It says the area of the larger rectangle is always 1. So I can write 1 for A. That's equal to the base of the large rectangle. How do I find the base of the large rectangle? And that's what we did in a different section. Okay. Yeah, the base of the large rectangle is 9 minus 4. Right? And we've already done that before at a different time. And the height, we don't know yet, is h. But hopefully, you can use a calculator, but hopefully you can do 9 minus 4 in your head. What is 9 minus 4? Yeah, 9 minus 4 is 5. Yeah, 9 minus 4 is 5. So it's 5h is equal to 1. Let me just rewrite equals 1. And if you want to get h by itself, we divide both sides by 5. So that tells you that h is equal to 1 over 5. Any questions on that? I'm going to make that bigger because it always gets small when it turns into a fraction. Any questions? Okay, now we're ready to answer the question, which is what is the probability that a randomly selected potato weighs between 5.2 and 6.7 ounces? And what it says a little earlier is that the probability is the area of the smaller rectangle. So now I'm going to write down again, even if you get tired of it, I'm still going to write it down. A equals BH. Because that's what we're going to be using on all this stuff. Any questions on this idea so far? Okay, now we don't know A. So we can say A is equal to the base. And what is the base, or how do you find the base of the smaller rectangle? Yeah, so we're going to take the 6.7 minus 5.2. Okay, and then times the height, which was 1 over 5, because that was given, or that was what we found. Okay, now what we can do is we can say, what is 6.7 minus 5.2? And that is 1.5. Again, you're allowed to use a calculator, but that one I can do in my head, but you may not be able to, and that's fine. You're not responsible for that, but you are responsible for knowing how to use your calculator. Okay, times 1/2. 1/5, sorry. Let's see if you can use your calculator on that. Let's see if you can tell me what it is. What is 1.5 times 1/5? Yeah, so 1.5 times 1/5 is 0.3. And that's the probability of randomly grabbing a potato and having it between 5.2 and 6.7 ounces. By the way, don't quote me on this. I totally made up all these numbers. If I really cared, then I would, go find the exact, distribution of medium-sized potatoes. Okay, but it's probably not too far from that. Any questions on this example? Any questions? Any questions? Okay. Let's see. Not too many. All right. I think we should do one more. And that is the following. I'm going to do one. I'm going to walk you through it because this one's a little bit harder. There's a little algebra in it. We'll do it again, by the way, later in this class, but it happens and it's one of the harder parts. So I want to make sure that you all get it in this class. It happens in stats in a big way. All right. So now the question is, I'll just call this part B, is what percent of all medium sized, sorry, not what percent, how many ounces is a potato, medium sized, such that 28% of all medium-sized potatoes are larger than this potato. And let me write down, in other words, what is the 28th percentile for medium-sized potatoes? All right, I need to show you the picture. If I don't show you the picture, then it'll be too difficult. And I think this will work. Let me see. Good, let me edit it. All right, so what we have something different now. I'm going to get rid of a bunch of stuff. So we don't have 5.2 anymore. We don't have 6.7. What we do have is that somewhere up here is some value of X that we don't know. That's the 28th percentile. Okay, we also know H. H is 1/5.
Yeah, take that out your mouth.
Okay, so H is 1/5. And we know some more. So let me draw the picture. We know that the area of this rectangle is 0.28. Okay, so let you know in a stats class, this will be what you have to do yourself. In this class, you're not expected to do the whole picture yourself. It'll just be given to you. Okay, so I'm giving it to you. So now, what do you think the question is? What are we looking for? Any thoughts? So the picture, what don't we know? I don't see y'all jumping in. Still don't see y'all jumping in. I'd like to give you a little bit of time to think about it. The big rectangle, actually we do know the big rectangle. That goes from 4 to 9. It's got a height of 1/5, area of 1. So we know the big rectangle. There's one thing we don't know. If you look at the picture a while enough, what we don't know is X. Okay, the part that we don't know in this is X, because that's what we're looking for. X is the size of that potato such that 28% is to the right. So we want to find X. So just like we've done before, I'm going to write A is equal to B times 8. That always happens when you talk about area of rectangles. In this case, do we know the area? The answer is yes. And it's not 1 this time. We're looking at the little rectangle. It's 0.28. That's your area because that's given. What about the base? And I see one person privately messaged me with an answer, but hopefully some of you can get it too. What's the base of this rectangle, of the red rectangle, the smaller one to the right? The hint is it's not just gonna be a number, it's gonna be an expression. Y'all see it? Okay, if you don't, well, the base goes from x to 9, and you always do the right minus the left. So it's going to be 9 minus x. Good, good. And the height is 1/5. Sorry about that. So the height is 1/5. So now we got to get x by itself, and that's going to take a little bit of work. So I'm going to multiply left and right by 5. And I can say that 5 times 0.28 is equal to 9 minus x. Any questions on that? That's how you get rid of a 1/5. Okay. Now what I can do is I can subtract 9. That's how you get rid of the 9. So when I subtract 9, I get 5 times 0.28 minus 9 is equal to negative x. And let's see if you can work this out. You can use a calculator if you want. 5 times 0.28 minus 9. Okay, I got it in my head. Let's see if you can get it. You can use a calculator, but I do want to see you practice whatever calculator you have. But every calculator can do this. Okay, unless you're weird like me and you like doing these things in your head, but most people don't. Yeah, 1.4, well, close. Negative 1.4 when you do the subtraction. Negative 1.4 is equal to negative x. So if negative 1.4 equals negative x, then negatives go away, and you can say x is equal to 1.4. Wait a minute. No, it's not negative 1.4. Yeah, it's 7.6. I think I should tell you all that. And then x is 7.6. Which I know because it's got to be kind of close to 9. One of my faults, by the way, is sometimes I trust people when they send me a message on the what they think the answer is. And I think, wait a minute, that's not what I got. Okay, any questions? Any questions at all on this? So in words, by the way, a potato that weighs 7.6 ounces is such that 28% of all potatoes, all medium size potatoes, are larger than that. Any questions on this example? Okay. These are tough. We're going to do this again, by the way, in about 3 weeks, but I couldn't resist myself because it comes up and students have so much trouble with it in stats. So I figure it can't hurt to show you twice. Hopefully, if I show you twice and you work on it at least once or twice, then when you get to stats, you'll be able to do it. Because it's one of the harder algebra pieces that people have trouble with. Okay, so now what I'm going to do is the next thing. I'm going to give you a definition. And that is this guy. This doesn't mean let's shout the letter N. That's not what the exclamation point is. This is called N factorial. And is defined as N factorial is equal to N times N minus 1 times N minus 2 times all the way down, and N may be small, but I'm going to assume it's big, times 3 times 2. If you want, times 1, just to make it look pretty. You don't have to do times 1, though. And this is called N factorial. Have you seen this before? Maybe individually you can tell me. Have you seen it? Okay. Okay, some of you have never seen it. It's kind of a new arithmetic. It comes up in statistics for all kinds of interesting reasons, especially the next thing we'll do. Just note, by the way, N factorial gets big fast. So let me give you just some easy examples. Let's say 5 factorial. Well, that's equal to 5 times 4 times 3 times 2. You don't have to put the 1, so I'm not going to. Okay, and that is equal to, what is it? See if you guys can do it. Yeah, 120. How about 52 factorial? Okay, that was an important number for me in my younger days, before my life was threatened. Anyone know why? What's special about the number 52? No one does? It's the number of cards in a deck. Anyone know why my life was threatened? Because I was a card counter. And the mafia basically said they're going to kill me if they ever saw me come back to Las Vegas. Okay, that was the old days when the mafia was in charge. And I never went back. I've never gone. Okay, so yeah, it was, but you have to be able to do this kind of stuff. Now, 52 factorial, that one, the last thing we want to do is sit there trying to calculate the sucker. So it's 52 times 51 times 50 times 49 times 48 times 57. You'll be there for days working the sucker out. But the good news is it's actually quite easy. We can just go into Google and just type in 52 and an exclamation point and hit enter. There it is. Okay, do you know what that means? How do you read this number? Yeah, it means it's 8.0658175 times 10 to the 67th power. So it's important that you know how to see that. They always use E on these kind of calculators. Okay, the TI-84 uses the E also. TI, I think, uses capital E instead of lowercase, but same idea, doesn't have plus. Okay, so that means it's going to have 68 digits. Okay, This is huge. Okay, there are more. This is bigger than the total number of grains of sand on Earth, just to give you an idea how big this number is. Okay, this is gigantic. Okay, I think it's more than the number of molecules on Earth, actually. It's a huge, huge number. Factorials get big fast. Okay, any questions on this so far? All right, let's do another factorial. So I guess I should answer it. Easiest way is this. Copy and paste it. There we go. Let's go back to regular font. Okay, so what about the following? So where do you find one on the T84 calculator? Okay, so how is it that I happen to know exactly what you're going to ask? So here's what we do, and we're going to do a few things in this spot. You're going to type in the number, like 52. So don't read the step 1, step 2 quite like I'm reading it, but basically just type in 52. Then you're going to press the math button. Then you're going to go to PRB. Okay, don't read step 3 and step 4. Then you're going to go to number 4, factorial, this exclamation point, hit enter, and I think you have to hit enter one more time. So does that totally answer your question? So again, you're going to go to math, PRB, and then scroll, go down with the down arrow to 4, and it'll show a factorial, hit enter. I think you could type 4 too if you want. Okay, and that'll get you this factorial. All right, let me give you another example we can do without a calculator. What is 25 factorial divided by 24 factorial? Anyone know that? Anyone could look at that and tell me? Without using a calculator. It's not one good try though. Okay, let's think about this. This is going to be, the numerator is going to be 25 times 24 times 23 times ... times 3 times 2 times, well, I won't do the 1. The denominator is going to be 24 times 23 times ... times 3 times 2. And now you can cancel. And here's the question I have for you. What doesn't cancel in the numerator and denominator? So what doesn't cancel? The hint is just about everything cancels, but something doesn't. So what doesn't cancel? Okay, it's not one. There's one thing that doesn't cancel. Look at the numerator, look at the denominator, and they're not the same. Not a factorial. Here's a hint. They both have a 2. They both have a 3. They both have 4, etc. They both have 24. The 24s cancel. Do you see that? I see a 24 on the top. I see a 24 on the bottom. The only thing that doesn't cancel is 25, and that's the answer. Everything else cancels. Isn't that nice? So I figured I'd give you an example you could do without a calculator. Anyone lost on what I just did? Noticing that everything canceled except the 25. So that's what we got. You have nothing left in the denominator. That means it's a 1. And you only have a 25 in the numerator. 25 over 1 is 25. Any questions on that? Okay, so now comes the next big definition. And that is NCR. Sometimes we'll see it as NCK also. They use different letters. Represents the number of selections of different R items from N items when order does not matter. I like does not. It one doesn't. Okay. This is called, the C stands for combinations. It's the total number of combinations you can get by selecting R items from N items. Any questions on this? Okay, the formula is the following. NCR is equal to the fraction n factorial divided by R factorial times n minus R. Let me make that bigger. Factorial. Okay, so for example, what if we had 52 C 5? By the way, first thing, what does that represent? Kind of in words before we get into the formula. If you read the definition, what does that represent? Any ideas? Yeah, so it means that you are selecting 5 different items from a larger collection of 52 items, and you don't care about the order. Where in the real world is this used? This particular 52C5? In one word. Yeah, counting cards, but in particular poker. Yeah, this one's poker. Okay, this is how many poker cards there are. Poker hands. Okay, the number of poker hands is going to be 52C5. Okay, we could write that as 52 factorial divided by 5 factorial times 52 minus 5. 52 minus 5 is 47. Any questions on that? Okay, so let me show you the hard way of doing it. This isn't even going to look that hard, but I'm going to do it anyway. So if we go 52 factorial divided by 5 factorial times 47 factorial. You get a little more than 2.5 million. Any questions on that? That wasn't even that hard, was it? But it turns out there's an easier way. Okay, so by the way, there's a little more than 2.5 million different poker hands. Okay, that's a lot. You can't keep track of them all, but I will tell you, you can do math and learn poker with math. I used to teach a class called the Mathematics of Poker. Okay, way back when, and it was just it was a 1 day long, a full day class is what it was. I don't do that. I don't teach that one anymore. Now they want us to just teach regular old math classes, but it was a fun little class. And I talked about how you look at all the different poker hands and all the numbers and stuff like that. And they all use this factorial and combination stuff. Any questions on this example? Any questions? Okay, here's another example. And oh, let me show you one more thing. Now I could go to this. This is actually what I had in mind before you asked the question. These are the 4 steps to do combinations on the TI-84 calculator. You first type in the number. In this case, the first number is 52, not 25. Okay, you press math, go to PRB. You can use the right arrow to select the menu at the top. Okay, select 3, CNR, press enter. Then type in the second number, in that case it's 5, press enter, and you should get a little more than 2.5 million. And that's how you use the TI-84 calculator. Okay, and every calculator is a little different, but advanced calculators all have this function. Okay, let me show you another application. It's kind of a fun one. And that is Mega Millions. Anyone play Mega Millions? Okay, you've heard of it? It's one of the lottery games. Okay, if you win, if you play, it costs $2, I think, to play, and you win $274 million. I think it's over a 30-year time span, but if you have that much money, you should never get greedy. Okay, so let me show you how you play. Okay, so the way you play, step 1 is you have to go to a retailer, spend your $2, and you gotta buy a ticket. And what you're gonna do is you're gonna pick 5 numbers between 1 and 70. Okay, and 1 mega number between 1 and 25. Got it? Okay. So here's the question I have for you. How many different choices do you have? And by the way, the 5 numbers you pick, you can't repeat, and the order doesn't matter. But your mega number can be the same as one of the 5. Okay, so we want to figure out how many choices you have to pick this lottery. And more interesting, because most of the time you just go to the lottery, retailer and say, "Get me a lottery ticket." You give them $2 and they give you a ticket. Okay, if you ever bought a lottery ticket, that's how it goes. So another question I might have for you, is it a good bet? And I'm gonna take away some of the details that matter, but we're gonna pretend they don't. And that's things like you have to pay taxes. That's definitely a detail. And 30 years might be an issue, and there's some other things. But basically, is it a good, just thinking that you're winning the $274 million is a good bet. So in other words, how many different numbers are there? And let's compare it to what you're gonna win. Any questions on the question? Any questions? Okay, well, let's go check it out. So for the lottery, what we're going to do is we need to pick 5 numbers from 1 to 70. Okay, so I'm going to pick 5 numbers from 1 to 70. And the question is, how many different choices do we have? How do you figure out how many choices you have? Yeah, that's going to be 70 C5. But then we have another number we have to pick. So we're gonna do what's called use the multiplication principle. We're gonna multiply it by the number of ways of getting one number out of 25, which is just. Any questions at all on this setup of the calculation? Okay, so now what I'm going to do is I'm going to show you again. If you don't have the T84 calculator with you, which is fine. If you have it, you know how to find the combinations. If you don't, then here's what I do. I just write combinations calculator. I didn't have to type the whole thing. It just knows. And I'm going to go to calculator soup. Sounds good. This one works. Google's great. And it just says, let's do it. And I want to show you, see this N with an R below it? That's another way of writing the same thing. So I'll write C and comma R. There's a lot of ways of writing combinations. So here's some more that calculator soup does. Our N was 70. And our R was 5. Okay, and what we get, let's go back. We get that times 25. They use the capital E like the TI. Let's write this out. It's this times 10 to the 7th power. So we move the decimal over 7 places. 1, 2, 3, 4, 5, 6, 7. So in a way, you just don't need a decimal. Let me double check that was right. 70 C5, yeah. Was this guy with 7 decimal places. Is that clear? Then what I do is I need to multiply that by 25. And it's small, so let me make it bigger. I don't know how it got so small. There we go. That one we can easily do with any calculator. We don't need to go to calculator soup or anything. You just go to Google and paste it in, hit enter, and there's your answer. And let's put that in. It helps, at least for reading, to put some commas in. So how do you read this number? Is it big? Is it small? You think you can win? If you buy a ticket, you think it's pretty likely you're going to win or unlikely? What do you think? Yeah, not at all. It's 1 in 302,575,350 chances of winning the lottery. Okay, and notice that if you do win, you get 2.59 million. Okay, but you have 1 in 3.02 million chances. It turns out if you're looking to see if it's worth it, in quotes, to play the lottery, it should be double that number. So if the lottery goes above 605 or so million, then it's kind of not such a bad bet. Okay, there's taxes, so you got to worry about that too. So ignoring the taxes is not such a bad bet. Okay, but right now it's not a good bet because you have a 1 in 302 or so, 303 million chances. And we're talking about 274 million was the winning, not the 259. That was the other one. But you win 274 million. Any questions on this kind of little lottery example with combinations? Okay, so if you ever want to find out how many ways are there of selecting a certain amount of individuals out of a bigger group, and order doesn't matter, then it's always going to be this NCR. All right, what I'm going to do now, because it's that time, is give you a secret word. And the secret word of the day is subtract. Because when you want to find the area of the rectangle and you want to find the base, you subtract to get the base. You take the right minus the left, and now it gets you the base. Let me put that red for a moment. So any questions? Okay, I think I'm going to stop the recording.